Hey guys, Mr. Prosky here. Hope you're having a good day so far. We are continuing our chapter 11 of geometry, and we're working with area of different types of shapes. And so why don't we go ahead and read the name of the lesson. Ready? 1, 2, 3. Areas of trapezoids, rhombuses, and kites. Essential question. Ready? 1, 2, 3. How do we find area of trapezoids, rhombuses, and kites? Okay. So if you recall, a trapezoid looks something like this. A rhombus, squares were rhombuses. A rhombus needs to be something that's kind of what makes something a rhombus? You need all four sides need to be congruent. And a kite, and I'm terrible at drawing kites. I don't know if you guys remember there. I goofed up already. That wasn't too bad. I had the thing to help me fix here. So kites are going to have pairs of congruent sides, but they're going to be side by side next to each other instead of like a parallelogram, which is going to be kind of like this. Or that was really bad. But for a parallelogram, these are congruent and these are congruent. Okay? So this is a trapezoid. And also, what makes me a trapezoid is one pair of parallel sides. Okay? A isosceles trapezoid is going to have congruent angles, base angles like this. Okay? Alright, so we're finding areas of these three shapes today. Hopefully it's going to be a pretty quick and easy lesson. A lot of these are just using the formulas, so they're not too crazy. But alright, the height of a trapezoid is going to be the perpendicular distance, the what? Perpendicular distance between its bases. And the area of a trapezoid, the formula is the area equals 1/2 the height, and then in parentheses times base 1 plus base 2. Now remember, this is an exponent. This is a label. When it's super text, it's gonna be when it's like this is gonna be an exponent. When it's down in the lower right like this, it's just a label. Okay, so it's not an exponent. Just don't confuse that. Okay, this is basically just labeling base 1. Oops. Base 1 plus base 2. Or another way we could write this is area of a trapezoid is going to equal height times base 1 plus base 2 all over 2. Instead of doing the 1/2 in front, we can also just put it all over 2. Okay, and that's the formula. It's kind of complex, but hopefully it's not too bad. Let's see here. Yeah, so this next problem might be a little bit tricky because it's got a square root in it, but we will just plug it into our calculator. So, you guys may want. I haven't really looked into calculator apps. I just know that the iPhone calculator really sucks. It's really bad because it doesn't let you like plug in like a whole expression. It just like does like one number at a time. So you may want to look into. I might post some kind of calculator apps for you guys to look into that will be better. I'll see if I can do that today, hopefully. But for now, example 1 says find the area of a trapezoid. To prevent beavers from damming a drainage pipe, the trapezoid-shaped fence shown is placed at the pipe. Approximate the area enclosed by the fence. Okay, well, if it's the area of a trapezoid, we need the height, we need the base 1, and we need the base 2. Okay? And like we said up here, the height is the perpendicular distance between the bases, and the bases are the parallel sides. Alright? So what do you guys think the height is for this? We got, 5 numbers to choose from here? Which one of these is the height? Hopefully you said 8 square root of 2. 8 square root of 2 is the height because it's the perpendicular distance. It's the distance between the two bases, which are these right here. And I kind of gave away the bases, but these are the parallel sides, and those are the bases. So that means we're going to have base 1 could be 16, and base 2 is 8. You could also reverse those and call this 8 and 16. It's because you're adding them together, it's not going to matter. They're interchangeable. Excuse me. All right, so we're going to plug into the formula. So we're going to do area equals, make sure you guys can see that. We're going to do height times base 1 plus base 2 all over 2. So we're going to plug it in. So area equals the height was 8 square root of 2 times base 1 was 16 plus 8 all over 2. So area is going to equal, we simplified that some more, 8 square root of 2. What's 16 plus 8 going to be? That's going to be 24 all over 2. And then if you were using your calculator, I would not plug, like, you can either plug this all in if you had an actual calculator. Otherwise, what I would do is I would just multiply the top, and then I would divide by 2. That's the kind of the shortcut. If you have like a big fraction like this, just go straight across the top and then straight across the bottom and then divide those two numbers. I feel like you had like 2 times 14 square root of 3. I would multiply these together, equals, write down the number over here. These are what they're equal to, write down the number over here, and then divide them. Okay? But we just have 2 on the bottom. So 8 squared root of 2 times 24 all over 2 is going to be approximately, not equal to, approximately 135.76. Is it feet or feet squared? Well, it's area, and that's going to be square footage, so it's going to be square feet. Okay? All right, that was kind of wacky with the 8 squared root of 2, but if it's hopefully we don't have ones that are that tricky in the actual quiz and stuff. So, all right, moving on. This is kind of nice. We have area of rhombus and kites, and they have basically the same formula, no matter if you're using a rhombus or a kite, okay? So the area of a rhombus is 1/2 the product of the lengths of its diagonals. Basically, what that's saying is the area is 1/2 of this diagonal times this diagonal. And they just put them on the side here so you can see them, I guess, a little bit better. But so yeah, so all we're going to do is we're going to put 1/2 of diagonal 1 times diagonal 2. Okay, diagonal 1 is like this, diagonal 2 is like this. The diagonals go from corner to corner of a rhombus or kite. The same thing for a kite. It's also going to be 1/2 of diagonal 1 times diagonal 2. That's going to be the area, that's going to be the inside of this rhombus or kite is 1/2 of the diagonals multiplied together. Okay? It's kind of cool that those formulas work out that way, even though it's kind of hard to see where those come from, but okay? All right. So one thing we got to be careful about is, we'll look at example 2 here for a second, but it says, find the area of a rhombus, find the area of the rhombus. This is kind of twice there, but, so one thing we have to be careful about is what it's pointing to here. So this is pointing right here to this diagonal, and this 11 is pointing to this diagonal. But what you need to be careful about is sometimes it'll be pointing to, does this 8 mean this entire length? Or does this 8 mean just this part right here? Okay, and does this 11 mean just this part? Or does it mean this entire thing across? Okay, so what we gotta be careful about is what it's asking here for. If it's a rhombus, I would just say that it's just all the way across. Okay, a kite is gonna be different because it's gonna have, if you look at like over here, if you look back at the kite, this length right here is longer than this length right here. Okay, so that's why they might have different lengths. We gotta be careful about. Okay, and all you would do in that case is that you would add the blue and the green. You would add those both together to get your other diagonal. But, one thing I forgot to mention that's very important and pretty easy. Instead of doing 1/2 of diagonal 1 times diagonal 2, we can also do diagonal 1 times diagonal 2 all over 2. I really prefer that. I think that's a lot easier to work with than doing the 1/2 in front. So, okay. All right, let's go ahead and do this problem then. So we have area of this rhombus is going to equal diagonal 1 times diagonal 2 all over 2. So we need diagonal 1 and diagonal 2. So diagonal 1 is going to equal, what do you want to use, 8 or 11? If you said 11, sorry, I decided that we're going to use 8, but it doesn't really matter. Diagonal 1 and diagonal 2 are interchangeable, which means diagonal 2 is going to be what? It's going to be 11. Then we just plug it in. So we're going to do area equals, well, we got diagonal 1 was 8 times diagonal 2, which is 11, all over 2. 8 times 11 is 88 over 2. So the area, and then 88 divided by 2 is going to be 44. It's centimeters, and it's going to be centimeters squared because it's area. Okay? All right, let me look at a couple of these examples here. These checkpoints. Yeah, why don't you guys go ahead and pause the video and try checkpoint 1 and checkpoint 2. And we will, we'll go right there. So go ahead and pause the video. All right, welcome back. So we're doing checkpoint 1. We're looking for the area of each polygon. So what is the shape of checkpoint 1? That's kind of a shape I don't really recognize. Well, we're using rhombuses, kites, or trapezoids today. Which of these shapes does it look like? Yeah, because these are both right angles here, that means that these sides are going to be parallel, which means we're working with a trapezoid, okay? And the area of a trapezoid was the height times base 1 plus base 2 all over 2. So what's the height of this trapezoid? Height's between the two bases. What's the perpendicular distance there? It's going to be 4. Then base 1 we're going to call what? 7. And base 2 is 9. If you call base 1 9 and base 2 7, that's totally fine. Doesn't matter. So area is going to equal our height, which is 4. Excuse me, times base 1 plus base 2, so 7 plus 9. All over 2. Area is going to equal 4 times, what, 16? All over 2. And area is going to equal 64 over 2. Which equals, it's not approximately, it's equal to, because it's a whole number, 32 feet squared. Okay? All right, next example. What kind of shape is this? It looks like all four, we have tick marks here, 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 and here. These are all congruent, which means it's going to be what kind of shape? It's going to be a rhombus. It's going to be a rhombus. So we're going to use diagonal 1 times diagonal 2 all over 2. That was sloppy. Let me fix that. So diagonal 1 equals 12. Diagonal 2 equals 18. So we're just going to plug it in. Diagonal 1 was 12 times diagonal 2, which is 18, all over 2. So that's going to be 12 times 18 is 216, all over 2. And area is going to equal 108 meters squared. Okay. Now let me look at this next example, because it looks like it's kind of confusing. I don't want to confuse you guys too much. Okay. So this next example is pretty tricky, and I don't think I want to confuse you guys too much. I think we'll just stick with this for now. I'm going to make up a problem really quick right here and see how we do, see how this works. Let's say, so we're not going to do this one, this one's trash. Let's say the area of a, I don't know if this is going to work out perfectly, but I want you to be aware of how to do these kind of problems. So let's say the area of a trapezoid is 100. And let's say we're looking for the height. We have base 1 equals 12 and base 2 equals 5. Okay, so we're going to do a problem like this I just made up now that's going to be a little bit, just so you guys are aware of how to do these types of problems, okay? So we're doing area of a trapezoid, which is height times base 1 plus base 2 all over 2. And we're going to solve for the height. We're not solving for the area anymore. We know the area. The area is going to be 100. Okay? So this is kind of what this next problem was trying to do, but it's kind of clunky and kind of nasty numbers. So let's make this a little bit easier for you, okay? So the height we don't know. So we're going to be doing like we did before with like the solving for the base or the height of parallelograms and stuff like that. So we don't know what the height is. What is base 1 plus base 2 going to be? That's going to be 12 plus 5 all over 2. So 100 equals the height times 17 all over 2. Now, how do I solve for h? I got kind of 3 numbers here I'm working with. Well, first thing I'm going to do is get rid of that denominator. How do I get rid of dividing by 2? I'm going to do what? I'm going to multiply by 2. So we're going to have 200 is going to equal h times 17. And now how do we solve for h? What's the next step we do to solve for h? We're going to, whoa, that freaked out there for a second. Sorry about that, guys. To undo multiply by 17, we're going to divide by 17. So the height is going to be approximately, this might be a kind of a weird number, but we'll see. It's 11.76. Okay? So that's the same kind of problem, but we're solving for the height instead of the area of the kite or whatever, okay? Or the, yeah. Let's do another problem with, let's find diagonal 1. So let's go ahead and, so the area of a kite is 54, and we know that diagonal 1 equals 10. We're looking for diagonal 2. We don't know what that is. Okay? So similar kind of problem. We know the area of a kite is diagonal 1 times diagonal 2 all over 2. Okay? So what am I going to plug in for area? Area is 54. Diagonal 1 we know, which is 10. Times diagonal 2, which we don't know, all over 2. Okay. Now, how do we solve for diagonal 2? We got to get rid of that 2 in the denominator, so the same thing we did before, we're going to multiply by 2. 54 times 2, we believe, is 108. Yep. Equals 10 times diagonal 2. And then how do we solve for diagonal 2? By getting rid of that 10, we're going to divide by 10. So diagonal 2 is going to equal 10.8. Okay, so there's two examples where you're solving for different parts of the trapezoid, rhombus, or kite instead of looking for the actual area, okay? So I think we're going to skip these last two examples because I don't want to confuse you guys too much, and hopefully those last couple are a little bit helpful. And I'm going to cross these out. Okay? All right, thank you guys for watching. Hope you have a great day, and we will talk soon.